Today we're going to learn how to use the lift and drag force balance system. So right here you see the force balance itself. Then you need the cable to connect it to the digital readout. You need the calibration source mounting system. You need the airfoil mounts for them. You can see here you got two blanks for connecting in the hole here on the wind tunnel. The pressure tap one. And you can see you got one for the 0012 and the 4412. Pick the one that you're choosing respectively. So you have one for the 0012 and the 4412. You will need the actual 4412, which is this one. You can tell it's the 4412 because the way it's cambered. And the 0012, you can tell this is a 0012 because it's symmetric. You will also need a strand of wire, a weight set for calibration, a screw to mount the wing to the stinger itself, and a set of Allen keys that come with the wind tunnel itself. Everything but the weight set will be inside the cabinet itself. These, the model wings, the Allen wrenches, the blocks, and the screw will all be found inside the bin in the bottom drawer. And the stinger itself is in the top drawer along with the calibration fixation unit. So the first thing we're going to do is set it up for calibration. So I'm going to go ahead and move the airfoil units out of the way. Now what you need for calibration is this fixture unit. And what we have to do is turn the balance on its side, like so. You're going to take the bag of Allen wrenches and you're going to figure out which one fits into this silver hole, this silver screw hole there. So you see a silver screw right here and a silver screw right here. You're going to put your Allen key in it and you're going to loosen that screw to separate the force balance system from the bottom test section, acrylic section that holds it in place when you're actually using it. And you're going to set the screw off to the side for the time being because you're going to need to use it for the calibration. And then you remove the bottom piece and set it to the side. Now, what you need to do next is you got to take the little unit. We'll first calibrate for the lift. So what you're going to do is mount it upside down on this like so. You notice right here and here there's two holes to put screws in. And you see the two holes on the bottom of this. So you go ahead and line up the screw holes. And then use the same Allen wrench you just used and the same screws. And you're going to screw it into this bracket for calibration. Do not over tighten these screws, just tighten it until it's tightened by basically hand, not over torquing it. So like so. And then go ahead and screw the other one in. So now once you have it mounted on the back of the digital pressure transducer and lift and drag unit, you need to plug in the one end of the cable right here, and it says danometer, which means the force balance. So that's where you plug it in there. Then you're going to grab the power cable that's in the bottom drawer of the black cabinet inside the bin. You're going to hook it to the back there. So when you're doing the lift calibration, you go ahead and put it upside down and screw it in these two holes using the same Allen wrench that you had taken it off from the plastic acrylic piece here. And now you're going to take the other end of the wire that you hooked into the back of the digital pressure transducer and force balance system, and you're going to go ahead and connect it to the force balance itself. And finally, we're going to calibrate the lift. The first thing you're going to do is turn the reading unit around so you can see the voltage display. And then you go ahead, you're going to go ahead and plug it into the wall, and go ahead and turn the power switch on the back, and you'll notice the voltage display lights up. Now, on the right here, you can see it says lift and drag, and you notice this little span dial. What this is it determines the amplification, so it amplifies the voltage output of the force balance itself. And you're going to want to set that to what you want it before you calibrate. You're calibrating based on the voltage being displayed. So if you're trying to find smaller change, you're going to want to have this at a higher amplification. Right now it's just set to 0 amplification, but if you wanted to set it, you just turn the knobs and you'll start seeing that the number will go up once you go all the way around. So you see that it goes from 0 to 90, and then once you do it, you turn it and you'll see a 1 here. So you notice there'll be a 1, and then if you keep on turning it to the right, it'll eventually turn to 2 and so on. So I'll keep it at 0 for right now. So we're going to calibrate first the lift one. So what you're going to do is, you notice how this thing is upside down so that when you apply a weight to it, it pulls straight down. So what we're going to do is we're going to take a bit of wire that we had. First we'll loop it through the little hole in the sting that you see. Pull it through. So you put it through the hole and you put a loop around it, then you twist it. And then you take a weight set, like the one that we used for strain gauge lab, and you're going to hang a known weight onto the unit, and you know the weight so you can calculate the force, and then when you apply that known weight, you look at the voltage display and you make note of the voltage display. So right now it's at 0.207 with a 500 gram weight. If I take that weight off, you notice that it goes down to 0.05354. And then I can go ahead and hang another weight on. So let's say I hang a 200 gram weight on it. Then we notice at 0.117116. So you notice there's a voltage change. So then you put known weights and known masses, and you calibrate it based on the known force that you're applying. And you're doing it for lift by itself in this current setup. So you're going to find the curve of weight, which will then become force, to voltage output. So you're calibrating the known force being applied to voltage output so you can find the force of lift when you have the airfoil in the test section. You can zero the voltage output of the system before you calibrate it by using this knob right here. So if I look at the digital manometer part, I'll start turning the wheel, and you notice that it'll start turning in a certain direction, and I get it as close as I can to 0. These are very touchy, so if you don't get it exactly at 0, that's okay, but you can at least change the offset close to 0. You can see it's very touchy, so then you can zero it out before you start your calibration. And that's how you calibrate for lift. Now there is a limitation on how much force this unit can display, and that limitation is 35 newtons, which is equivalent to 3.5 kilograms. So do not put more than 3 kilograms on this unit and you'll be fine. So calibrate between 0 and 3 kilograms when you apply weights to this. And now, once you're finished with the lift, we need to go on to the drag. So we're going to go ahead and leave that loop of wire on the unit. We're going to now take that same Allen key, start unscrewing it from the unit, using both screws. Make sure it doesn't drop on the floor as you're doing this, so go ahead and hold it down. And then now you're going to move it, and you notice right here there's two more screws. What you're going to do is turn it sideways like so, and then you're going to line up the holes, and you're going to again screw it in. You're going to do it for both the top and bottom. You can calibrate for drag. And what you're going to do is hang weights down, and this will induce the drag voltage change. And you can see that on the display there. You see it's 0.3 minus 0.308 with the 500 grams. I remove it, and it's giving me 0.026. So you can go ahead and calculate the voltage change based on that. So you go ahead and hang different masses on there. Our maximum force this can read is 22 newtons. Now, if you convert that to kilograms, that is 2.2 kilograms. So do not put more than 2 kilograms on this when you're calculating drag and calibrating voltage versus force. So you're going to hang weights, which will be a known force, and you can convert the force to voltage and calculate voltage based on the force. And then in the end, when you are looking at the airfoil in the wind tunnel and you're reading the force, you can see what voltage reading it is, and based on that voltage reading in your calibration, you can get the force of drag. Now, just like lift, you can zero it. And to zero it, you'll see another knob here. It's on the bottom when it's in the drag calibration. And you can look at the voltage, and you can see that it changes based on how you turn it. So you can zero this out before you calibrate it as well. And again, these are finicky, so keep that in mind when you are calibrating them. And you can see I got it to 0. So you can zero it out, and then we can apply a weight of, say, 500 grams. You apply that known weight, and you get your voltage change. And that is how you calibrate for lift and drag. And again, remember that this span right here is the amplifier. So if you're looking for small changes in forces, you're going to want to turn this amplifier up. Same thing with the lift. Now, once you finish your calibration, go ahead and take the wire, and you're going to go ahead and set that in the bin so the next group has it. You're going to take the same Allen key, and you're going to go ahead and unscrew the unit from the calibration. Make sure it doesn't drop on the floor while you're doing this. Remember, when you are doing the calibration, make sure the weights hang freely over the edge of the table. Once you get the bottom loosened all the way, then do the top. Once you separate it, you go ahead and set it off facing upwards and move the calibration to the side. Go ahead and put your weight set away as well. Now we're going to need to take the section with the hole in it for this, and you're going to go ahead and put it back on it, and you're going to go ahead and turn the unit on its side. Most likely upside down is the easiest to do this, but make sure you don't drop it. And you're going to go ahead and screw it back in. So line up the holes. And you're going to screw it down tight. And once you do that, go ahead and place it back upright. Now, what we need to do is set the airfoil up on it. And you notice the way that it's sitting now with the With the cable coming out the back of the wind tunnel, pointing backwards this direction, what we're going to do is, you'll notice if you take one of the airfoils that this side's got a set screw and this side's got a through hole. So you're going to take the screw, you're going to put one washer first, you're going to line the airfoil. You see here, you're going to line the airfoil with the hole and make sure that the set screw is facing towards you. You're going to put the bolt in from the back side. So if I turn it around, we're putting in the bolt right here. You're going to want to take a flathead screwdriver to screw it in. And there's one in the bin in the bottom drawer where all the models are. So make sure the screw hole's lined up. Probably the best way to do this is to take the small Allen key, line up the airfoil, and then turn the set screw tight so the airfoil stays in place. Then turn it around and take your bolt and go ahead and screw it through. The reason why you want to do the set screw is that it makes putting this bolt in easier because the airfoil is no longer moving around. And you want to make sure the bolt goes all the way through and that you do it hand tight. Then you're going to turn it around. Put the washer in on the other side. And then you're going to lightly screw the nut on. Before you put it in the unit, make sure you untighten the set screw here and make sure you're able to turn the airfoil. So I can turn the airfoil fairly easily. So now that we have the airfoil set up on the unit, what we need to do is remove the blank base like we had done before. Set it off to the side, and now put the unit with the airfoil very carefully and line it up and go ahead and put it in place. Now we're going to remove the blank piece and we're going to put in the proper airfoil shape. This is the NACA 4412. You notice there's a line here to tell you the angle of attack. So I'm going to put it in like so. Then I'm going to turn it to 0 degrees. And now I'm going to take the top off. Of the wind tunnel. I'm going to line it up with 0 degrees so that it's close to it. Maybe tighten my set screw a little bit with the Allen key so that it's not so loose, but yet I can still turn it. And now I'm going to put the shape back on again, turn it to 0. I'm going to line the airfoil up with that angle of attack. So that's pretty close. Now what I'm going to do is tighten the set screw. Put the side unit back on. Turn it to 0. Tighten the set screws. Put the top back on. clamp it down, and then I'm going to start the wind tunnel and collect my data. And then, to change the angle of attack, what we can do is open this, unscrew the set screw, turn it approximately to what we want, check it with our angle selector. Say we want 5 degrees. Take the top off again and move it and line it up, and then tighten the set screw. Once you're done, take the channel shape of that specific airfoil out. Carefully undo the base for the force balance system while holding it. Carefully lower it. Now, to change the airfoil to the other airfoil, of course, when you run the wind tunnel, you're going to check it. Check the voltage outputs of the force balance itself. You're going to undo the nut for the bolt. Make sure you don't drop it. Then unscrew it, and you're going to screw the other airfoil on. Make sure you don't lose the washer on the opposite side where the nut is. Then take the airfoil off. Put away the airfoil units, the models, the blanks for the angle of attack. Make sure to screw the bolt back into the sting so that we know what bolt to use and it's not lost, so the next people using it have it. So go ahead and put it through enough to put the other washer and the nut on it. Then you're going to unhook. Then you're going to turn off the unit from the switch in the back, unplug it from the wall, unplug the power cord from it and put it back in the container. Unplug the cable from it, turn off the cable box, put all the Allen screws and the screwdrivers as well as the power cable for the digital manometer system back away, and put away the weight set and the angling bracket for calibrating this. Then the last thing you need to do is take the flat plate, the flat blank section, and put it back on the wind tunnel for the next person to use, so they can start with a clean slate. Then finally, take the blank hole cover, put it in, and screw it tight. And that's how you use the force balance system with the wind tunnel.